this video, we're going to take a quick look at a couple of new rules for taking the derivative, and that is the derivative of a product. So if f of x equals like g of x times h of x, how do we compute f prime of x? Okay, so first off, let's get one thing out of the way. The derivative of the product is not going to be the product of the derivatives. So just as a quick example, if g of x is equal to, say, 2x and h of x is equal to, excuse me, let's say x squared, then notice that g times h would be 2x cubed, right? And so the derivative of that would be our 6x squared. However, if you take the derivative of each one separately, g prime of x equals 2 and h prime of x equals 2x, and if you multiply those two together, you get 4x, right? And so 6x squared is not the same thing as 4x, right? And so the derivative of the product is going to be a little bit different, and so let's see how that's going to work. So we'll just take a quick look at the definition here, and we'll go ahead and take our function to be the product, so that would be g of x plus h. Oops. Let me change that to f times g. I'm going to find a formula for f times g because I'm using h in a couple different ways here. So that's going to be f of x plus h, g of x plus h minus f of x times g of x. And in order to get the formula, we just add and subtract a special term in the numerator. And that term is f of x plus h times g of x. Let's see if I can fit it all in here. And I'm just adding and subtracting the same term here. So nothing going on there. I'm running out of space. All divided by h. Good. And now I can factor the f of x plus h out of the first term. And so you see we're left with g of x plus h minus g of x divided by h, right? And so that takes care of the first two terms. And then we have plus, I can factor out a g of x from that. And what's left here is f of x plus h minus f of x divided by h. Good. Now, what you see here is when you take in the limit, the limit of the f of x plus h, we're going to assume f is continuous at least. So that's just going to be f of x. And then when I take the limit of the next term, that's g prime of x plus, and then this is just g of x times, the last one is f prime of x. Good. So that means we have a formula now for the derivative of a product. Now I should say our book uses this form. Notice that you could reverse this. So this is called the product rule, and I'm just going to write it a slightly different way. The product rule says that the derivative of f times g, I'm going to write that as f prime times g first, f times g prime. And the reason is because in the next rule that we look at, it'll be a little bit easier to remember if your original product rule is of this form. But for now, let's try this out. Suppose that f of x equals x squared and g of x is 3 to the x, and let's compute the product, the derivative of the product, x squared times 3 to the x prime. Okay, so one way to do that, you could just build a little table off to the side here. Your f of x is x squared, so f prime of x is 2x, and then g of x is our 3 to the x, and then g prime is 3 to the x natural log of 3. And so now, you could take it either way, but we're going to take the derivative to be f prime times g, so it's kind of going this direction, right? And then we'll take a plus, and then it goes in the other direction. So that's going to be 2x times 3 to the x plus, plus x squared times our 3 to the x natural log of 3. Good. And so this would be our product rule. All right. The next rule is going to be something that's similar. It's going to be the quotient rule. Oops. Okay, so in this case I want to differentiate f divided by g. And so again, you might guess that this is not going to be just f prime divided by g prime. It's a little bit more complicated than that. In fact, let's just go ahead and write it down here. As it turns out, the derivative of the quotient is going to be the derivative of the top times g minus fg prime divided by g squared. Okay, so this is the quotient rule. Now compare to the product rule. And actually this is why I wrote the product rule the way I did, was so that the order of these terms didn't change. Okay, and so these are the two rules that we're thinking about in this section. The quotient rule is not hard to show. It just takes a little bit of algebra, and I think we do a little bit in the activities. So we'll just leave it at that for now. And so in class we're just going to be practicing how to use these. Well, how much time do we have? I think we have time for one more rule. So how about, or one more exercise. So for example, h of x equals x squared divided by 9x plus 1. Let's compute h prime. So remember, it's the derivative of the top, so that's going to be 2x times the bottom minus the top times the derivative of the bottom divided by the bottom function squared. Good. Now typically, I'm not going to ask you to simplify that because it's easier to see what you're doing if you leave your answer in unsimplified form. Okay, that's how to use the quotient rule. All right.